Hello everyone, welcome to Catalysis by Vedantu. My name is Pahul, and if I'm audible and visible, you know the drill. Please write here in the chat box. So my dear friends, welcome once again to this chapter of periodic properties, and we are at the 5th episode. This is going to be the penultimate episode, the second last episode for this series, most likely. Cool. So in the previous few classes, we have discussed a lot about the periodic properties, how to build the periodic table, how to decipher the electronic configuration by looking at the periodic table. We have understood different types of atomic radii, ionic radii, ionization energy, and in the previous class I had introduced you to the concept of electron gain enthalpy and electron affinity. Yes, and we've also looked at a couple of anomalies or exceptions and features of this particular electron gain enthalpy, which in old days was talked about as electron affinity. Yeah, so this is something that you would remember from the previous class. So just to quickly recap this idea for you, that if you have a situation in which you are providing an electron to a specific element, you would form an anion. Yeah, and this particular process has a certain amount of delta H associated with it. This delta H, this enthalpy change, is known as the electron gain enthalpy. Mathematically or physically speaking, it is the energy released or withdrawn when an electron is added to a neutral gaseous atom to convert it into the negative ion. Okay? So neutral gaseous isolated atom, that's very important for us to keep for the standardization. Yeah. So delta H, e.g., it can be exothermic, it can be endothermic, right? And electron gain enthalpy, when it's negative, of course, it is exothermic in nature. When it is positive, it's endothermic in nature. And electron affinity was an older way of talking about it. It talked about a specific atom at absolute zero temperature. So at normal temperatures, this would be the relationship between electron gain enthalpy and electron affinity. But for all practical purposes, we need to neglect this term of 5/2 RT. What is R? What is T? We'll learn about the R, that is universal gas constant, in the chapter of gaseous state. T is just temperature in Kelvin. Cool. So this is something that we had learnt in the previous class, and we had looked at this graph as well. Yaad hai? We understood that oxygen family has negative values, fluorine family has negative values, which means they release energy when gaining an electron. Even the alkali metals have a negative value of electron gain enthalpy. Why is it so? Why does it make sense? Why don't we make sodium negative instead of sodium positive? Well, I have explained all the ideas in the previous class, that is the episode 4 of the series. The playlist is in the description box down below. Anyway, we had also understood that the noble gases, which are over here, will need more energy to capture an electron. You will have to force them to capture the electron. You will have to provide them the energy because they're already very satisfied with their electronic configuration. Yeah. Cool. So this is an idea that we had discussed. We had discussed about the successive electron gain enthalpies as well, and we had understood that every second, third, fourth electron gain enthalpy will be positive in nature. You'll have to force an extra electron in because negatively charged species, of course. And then we had understood why fluorine's electron gain enthalpy's magnitude is not as high as chlorine. Yeah. Fluorine's electron gain enthalpy is lesser than that of chlorine in terms of magnitude because of the electronic repulsion that you would face in case you are forcing an electron into fluorine. So this is what we had discussed in the previous class. Now, my dear friends, in today's class, we need to understand a little bit more about the trends of electron gain enthalpy, where are further anomalies, and then we'll solve some questions, and then we'll go to electronegativity. Cool. So पहले तो ये ग्राफ देखते हैं फिर से. Let's look at this graph, and what's going on in this graph? It's very obvious. It's just the electron gain enthalpy's value in kilojoules per mole versus atomic number. Okay, so on the y-axis, this is electron gain enthalpy. Fine. Now, my dear friends, over here, if you notice, the halogens are at the top of the table, which is no surprise for us. obviously they have to be on top of the table because they do not, halogens are very readily accepting an electron because they do not have their noble gas configuration yet, so they want to turn into a noble gas configuration. Yeah, if you look at noble gases, they're at the bottom of the table. Positive electron gain enthalpy value, they just do not want to gain an electron, they're happy already. So even zinc has fully filled orbital configuration. Yeah, for zinc we use the name pseudo noble gas element. Okay, for zinc, cadmium and mercury we use the name pseudo bolo to fake, pseudo noble gas elements. Okay, this is zinc, cadmium, mercury. Why? Because if you write their electronic configuration, they are a D10 configuration. Yeah, they are an ns to n-1 D10 configuration. So they have fully filled orbitals. They don't want to change their configuration either. Hence, they also do not want to accept more electrons into them. Pseudo noble gas elements. These are so called. Okay. Now, my dear friends, the rest of the things are pretty clear. Noble gases नीचे हैं, halogen सबसे ऊपर है, very obvious. Now, a few things that I would love for you to notice are these that I will encircle in the black color. Notice the low position of nitrogen. Notice the low position of beryllium. Beryllium is not fully filled. Okay. Beryllium does not have its noble gas configuration. Neither does nitrogen. Yeah, but we have seen exceptions of nitrogen and beryllium in our ionization energy as well, है ना, उसमें भी देखा था अपन ने कुछ तो गड़बड़ चल रही है इनके साथ. Yeah, so we had seen that in our previous class as well. Look at magnesium over here. Look at phosphorus. It is also a little under all the other elements like silicon, sulfur and chlorine, etc., etc. So these are a little interesting for us. Okay, these are a little more interesting anomalies for us, and this is what we need to figure out now. The rest of the table, not very important. You need to know halogens love to capture electrons, noble gases don't want to capture electrons. There are pseudo noble gases which are zinc, cadmium, mercury, and there are these elements like nitrogen, beryllium, magnesium, which do not want to capture electrons. Even phosphorus has a very, very, very less magnitude of electron gain enthalpy. Cool. So now let us try to understand these interesting cases, and since we have talked about them in ionization energy in our yesterday's class, not yesterday, in our class on Thursday, yeah, we'd be able to understand these cases better. But before I tell you about these cases, let me quickly tell you that since we are in these days of the lockdown where you can't join any offline coaching, it's better that you join an online coaching, and Vedantu has you covered. Okay. So if you want to join Vedantu as a full-term student, this is the link that you have to follow, vdnt.in/ytpro. It's got courses for all grades. If you're in 6th, 7th, 8th, 9th, 10th, 11th, 12th, any grade you have, any grade you are in, any class you're in, this will offer you courses. Now, the classes in this course will be live. They will be on Vedantu's patented platform. Yeah. I am using the whiteboard of that platform. There are much more features in this platform which you will experience if you join this full course. You will have live quizzes and visualizations, etc. You will have a double teacher model. A teacher will be teaching, the other teacher will be solving your doubts in the chat box. You will get a lot of assignments, you will get a lot of notes, because when you join a coaching institute, you get a lot of study material as well, and that is a part of the entire package. You will get a lot of test series analysis. So in case you want to know more details about the course, please open this link. The link is given inside the description box down below. So what happens is, when you join a full course, you are held accountable. People will keep asking you, whoever teaches you in the course will keep asking you, beta padhai ki nahi? So that keeps you on your toes when you have so many people studying around you. Even though if it is online, you always feel like, yes, you should also study. So that's the advantage of joining a full course like this. In case you want to, these are the coupon codes. You can try this course for 1 month. You can join this course for 3 months, 6 months, 12 months. All the options are there when you open the link. Cool. Check it out if you want to. Now let's get back to the matter at hand, and that was these interesting cases. Yeah. So we've got beryllium and we've got nitrogen, yes. So my dear friends, once again we are supposed to write the electronic configurations to explain their anomalies. Beryllium, 1s2, 2s2, as simple as that. So beryllium is what? Fully filled. That is why it is reluctant. You remember the meaning of the word reluctant? Reluctant means hesitant. Hesitant means sankoch karna, sakuchana. Sakuchana means sharmana. I mean, not exactly, but you understand, yeah? So, reluctant to gain an electron. Alright. Similarly, nitrogen, 1s2, 2s2, 2p3. So once again, we know that fully filled and half filled configurations are favored. So since this guy is half filled in configuration, yeah, this is also reluctant to gain electrons. That is why their electron gain enthalpies in terms of magnitude are very low. In fact, you have to provide them energy if you want to force an electron into them. And the thing is, if I talk about electron affinity, as I told you in the previous class, you have to think about electron affinity in more of a qualitative manner. ठीक है, electron affinity को आपको quality की तरह सोचना है. Do they have any love for electrons? No. That's what I will say, right? Do they have any love for electrons? No. So I can also say that their electron affinity is 0. Got it? Electron affinity, you can always think about it qualitatively. Think about it as the love for electrons. These guys do not love electrons. 0. Fine. Now let's solve some questions. But before I solve these questions that are related to electron gain enthalpy and electron affinity, I want to touch up on the homework for the previous class. So this is the question that I had given you. The increasing order of first ionization enthalpies of the elements B, P, S and F lowest first are. So this is how the periodic table exists. Yeah, this is the second period starting from, I've just started from boron. I didn't write lithium and beryllium. And if you go to the third period, you would have no need to make all of them, but still in case you want, I'll make it for you guys. Cool. ठीक है, ये न्यूजीलैंड लग रहा है यहाँ पे. This is neon. Okay, so the elements in question are boron, fluorine, phosphorus and sulfur. So my dear friends, two things that you should understand, that fluorine is the most non-metallic over here. Fluorine is the most electron loving over here. Yeah, so it does not want to lose an electron. So fluorine's ionization enthalpy, okay, we are talking about ionization enthalpy over here. So fluorine's ionization enthalpy would be the largest. You need to provide it the most amount of energy to lose an electron from fluorine. And for boron, it's going to be relatively simpler. Okay, for boron it will be relatively simple because it is way down the period. Okay, so you might get confused whether to keep phosphorus or sulfur below boron. This is an experimental value. You can check out the values of the exact electronegativities on this website called ptable.com. It's an interactive periodic table website. You just scroll on to the elements and you'll see all of their properties. So in the middle, you have to fit phosphorus and sulfur. Now you should remember that similar to nitrogen and oxygen, phosphorus and sulfur will show that weird anomaly. Yeah, nitrogen does not want to take any more electrons because it already has a half-filled configuration. Similarly, phosphorus does not want to capture an electron because it already has a half-filled configuration. And then over here you have your sulfur. So the final order will be boron, then sulfur, then phosphorus, then fluorine. It is a little tricky a question. It is a little confusing if you do not know the position of boron versus sulfur versus phosphorus. Yeah, so you might want to place boron on the top and then phosphorus and sulfur, but experimentally verified that this is something that does not happen. So other than that, the anomaly of phosphorus and sulfur, this is something that I've already told you in the earlier class. So the correct answer becomes D. Now, since we are carrying forward the tradition of the Hall of Fame, let me try to show you the names of the people who gave me the correct answers in the previous class the fastest. So here we are. As you can see, I have opened the previous session, periodic properties lecture 4, and if you sort the comments by newest first, it means the oldest comments are the fastest on the video. So let me go down and see. Okay, some random comments, and Sainath is saying, you're the best teacher, can you give your phone number? Sainath, thank you so much, but I hope you understand, if I give my phone number, then my personal phone number will become a chat support. So I hope you understand, man. थोड़ा मुश्किल हो जाएगा मैनेज करना. You can leave your doubts in the comment section in case you have any. Cool. So Mayur is saying the answer is FSPB. उल्टा कर गए दोस्त कुछ तो. Mayur, you've you messed it up somehow. Yeah, fluorine is gonna have the most amount of ionization energy. कुछ उल्टा लिख गए शायद तुम दोस्त. Yeah, something. Rudransh is saying E. I don't know what is E. So Kanav is saying D is the answer. Absolutely correct. Sainath is also saying D is the answer. Very nice. Another Sainath is saying D is the answer. Very good. Abhishkar is saying D is the answer. Rudransh is saying, do you teach in the Vedantu's Pro subscription? I teach over here at YouTube, Catalysis by Vedantu. That's all. I teach only at YouTube. Chalo. Shravanti is saying the option is, the answer is option D. Absolutely. D-Dematics. Very nice. Rafia, good job. Shivani, very nice. Lavanya, good. Fit G cracker the. Yeah, bro, cool. And ionization energy and enthalpy. Enthalpy is that specific quantity that we define. Energy is just a normal colloquial word for enthalpy. समझ रहे हो ना? ठीक है, एनर्जी बस ऐसे ही बोलने के लिए बोल दिया, एंड एंथैल्पी इज द एक्चुअल क्वांटिटी दैट यू मेजर आउट ऑफ दैट पर्टिकुलर प्रोसेस. चलो गगन, वेरी नाइस. बिफोर द बिग गैंग, ओके ग्रेट. नमनदीप, अदिति, गुड जॉब पीपल. If I take more names, then we'll spend the entire class taking names. So in case you were able to get the answer correctly, please give me a high five in the chat box. Yeah, just write high five in the chat box. If I was able to take your name, brilliant. If I wasn't, it's still fine, because if you got the correct answer, that's what matters. It's just a friendly competition. Yeah. So now, my dear friends, is time for us to solve these ones. Let us rack our brains again. We've been doing this section in the previous few classes of periodic properties as well. So chalo kare inko. First one, which of the following elements is expected to have the highest electron affinity? Bataiye. Which of the following elements is expected to have the highest electron affinity? So let's just try to write what these elements are. 2p5 is a fluorine. 2p4 is a fluorine. 2p4 is an oxygen. 2p3 is a nitrogen, and this guy is chlorine. If you remember, we have talked about it in the previous class that chlorine has more electron affinity than fluorine. The magnitude of electron gain enthalpy for chlorine is more than that of fluorine, because fluorine faces these electronic repulsions and it can't accept the electron as happily as a chlorine. Cool. So chlorine is the most electron affinity wala element in the periodic table, and hence our answer is option number A. Got it? Cool. Great. Sometimes you might choose this as a silly mistake. No, electron affinity is the property of an isolated gaseous atom. Electronegativity is different, and we'll discuss that later in today's class. Chalo. Next question. Which one of the following statements is incorrect? Let's try to see. Greater is the nuclear charge, greater is the electron gain enthalpy. Pretty much right. If you have more effective nuclear charge, more will be the electron gain enthalpy. Chlorine has a higher electron gain enthalpy compared to potassium. Yeah, isn't it? So greater is the nuclear charge, greater is the electron gain enthalpy. Pretty good. Makes sense. More effective nuclear charge, more electron gain enthalpy. So first statement is correct, not the answer. Nitrogen has almost zero electron gain enthalpy. That's also correct, because nitrogen does not want to gain an electron. So it's reluctant to gain an electron. Almost zero electron gain enthalpy. Very nice. Electron gain enthalpy decreases from fluorine to iodine in the group. Nah. Electron gain enthalpy, and we are talking about the magnitude. Now remember, in the previous class I told you that we always worry about the magnitude, not about the sign. Okay, we are not worried about the sign, we are only worried about the magnitude. The sign just tells us that we are releasing energy and not withdrawing energy. Yeah, so the sign for a chemist signifies release of energy or withdrawal of energy. Whenever we are saying greater electron gain enthalpy, you don't have to think about the negative sign, you have to think only about the magnitude. If they want you to think about the sign, they will mention it. Okay, they will mention it specifically that considering electron gain enthalpy to be a number, which number is the greatest, in case they want you to consider the sign. Otherwise, electron gain enthalpy in most colloquial I mean बातचीत के terms में, it's always just the magnitude. So electron gain enthalpy decreases from fluorine to iodine in the group. No, fluorine, then chlorine increase, then from chlorine to iodine it decreases. Cool. So this is the correct answer for this question because it's asking for an incorrect option. Yeah. And then last one says chlorine has the highest electron gain enthalpy. Yes, we just saw that in the first. पहले वाले में दिख गया. Cool. So the next question says the correct order of increasing electron affinity of the following elements is. This is also something that we saw yesterday. So the top will be chlorine, then you will have fluorine, then you have to judge between sulfur and oxygen. As I told you, oxygen has the least electron affinity in the entire family of oxygen. Yeah, so oxygen will be the least and sulfur will be over here. This is also something that we've discussed in the previous class. So the answer is option number A. Yeah, option number A is the correct answer. If you want to see the values, I will show them to you again. These are the values. Chlorine is 350, fluorine is 328, sulfur is 200, oxygen is 141. All right, electron affinity, this is the increasing order. Great. Now my dear friends, the next one, very simple question yet again. In which of the following arrangements the order is not according to the property indicated against it? Lithium, then sodium, then potassium, then rubidium, increasing metallic radius. Is this the correct order? Absolutely. Then increasing electron gain enthalpy, iodine, bromine, fluorine and chlorine in terms of magnitude. That's also correct. Chlorine has the most. We saw it in the last 3 questions. Great. Option number C. Boron, carbon, nitrogen, oxygen, increasing first ionization enthalpy. And this, my dear friends, is wrong. The order should be boron, then carbon, then oxygen, then nitrogen. Isn't it? मानते हो कि नहीं? Because nitrogen has that half-filled configuration, it does not want to change its electronic configuration. So its ionization energy is high, its electron affinity is 0. Yeah. So over here, the correct answer is C because it is mentioning the incorrect property. Yeah. You need to choose the property that's not the arrangement that is not according to the property. Cool. Last one says Al3 positive, Mg2 positive, Na positive and F negative, increasing ionic size. Absolutely. All of these elements, if you notice carefully, have 10 electrons. Yes. Fluorine has 9 protons, sodium has 11, magnesium has 12 and aluminium has 13. More protons, smaller size. That's exactly what's given over here for an isoelectronic group of species. So this is also a correct statement. This is the wrong statement. Hence the answer is option number C. Cool. So whenever you are solving questions in the examination, make sure you take care of the fact that they are asking you about the incorrect statement. They are asking you about the property that is not according to the order mentioned. Fine. So this not or incorrect has to be read carefully. ध्यान से देखना एग्जाम में silly mistake हो जाता है. मैंने भी बहुत किया हुआ है. Even I have done silly mistakes when I used to prepare for JEE. So in the main examination, make sure you don't make such silly mistakes. Fine. Now, my dear friends, we have been discussing these properties till now, which are, relevant to an isolated gaseous atom. We've been talking about ionization energy. We've been talking about electron gain enthalpy. We've been talking about atomic radius. We've talked about ionic radius, etc. So we've talked about essentially a single species. Yeah, apart from when we discussed covalent radius, etc., then we considered a bonded species as well. But in reality, that we have compounds. Almost all the compounds in nature are, they consist of different types of atoms. Pure elemental forms rarely exist. They do exist. You have hydrogen gas, oxygen gas, fluorine gas, even they are in a bonded situation. Or you have your noble gases which are not bonded. But lots and lots of things around you are such that they have more than one element in them. For example, water, H2O. You know what I'm talking about. So now is the time for us to discuss a property that is related to a bonded scenario. Not an isolated gaseous atom anymore. It is applicable in a bonded scenario. Okay. So now let's try to read up on this very important concept which we will use again and again in the entire course of chemistry, and that is electronegativity. What is it? It is a qualitative measure. Mark the words qualitative. Qualitative word बहुत ज़रूरी है. Let me try to show you the screen. मैं screen दिखाना भूल गया लगता है. हाँ, ये रहे. So this is the thing that you need to see on the screen. So what it says is electronegativity is a qualitative measure. Okay, it's a qualitative measure of the ability of an atom in a chemical compound to attract the shared pair of electrons toward itself. Let's read it once again. It is the qualitative measure of the ability of an atom in a chemical compound to attract the shared electrons towards itself. What does this statement mean? मैं हिंदी में बता देता हूँ. ये क्वांटिटेटिव मेजर नहीं है, मतलब इसको अपन नेचर से मेजर नहीं कर सकते. वी कांट मेजर दिस फ्रॉम नेचर. वी कांट ट्राई टू टेक अवे एन इलेक्ट्रॉन एंड सी हाउ मच एनर्जी इट टुक. दैट इज अ फिजिकल क्वांटिटी. एनर्जी इज अ फिजिकल क्वांटिटी. एनर्जी को मेजर किया जा सकता है कि इतना एनर्जी दिया तो इलेक्ट्रॉन निकल गया. सो ओवर हियर इट इज अ क्वालिटेटिव मेजर. यू कांट मेजर इट डायरेक्टली फ्रॉम नेचर. Okay, it's not an energy, it's not the release or involvement of energy. It can't be measured directly from nature. You have to define it relative to each other. Yeah, let's say you are comparing, I mean it's a very very pathetic example that I'm giving you, but try to understand. Let's say you have two people that you know, you want to compare how nice they are with each other. Can you say this guy is nice by 10 units, this guy is nice only by 5 units? Can you measure niceness in reality? No, right? It's just a relative phenomena. It depends on the person that he is talking to or she is talking to. Yeah. If some person is nice to you, that person may be rude to someone else. Yeah. So niceness is not a directly measurable quantity. You can say, to give an example, that if this guy scores 9 out of 10 in niceness, the other guy scores only 6 out of 10 in niceness. You can make your own standard, isn't it? And again, with different people, it'll be a different value, right? So you can't really decipher it from nature. Whereas something like how tall is one person compared to the other, you can simply take a centimeter scale, an inchy tape, and measure their heights. Yeah. So the same thing is happening over here to electronegativity. Like heights, electron gain enthalpy, electron affinity, those can be measured, but electronegativity is a relative qualitative idea, like the amount of niceness a person would have. Okay? So my dear friends over here, again let's read these statements that have been written. It is not a measurable quantity. It is defined relatively, as I told you. It is not constant for an element. It depends on the molecule and surroundings. As I told you, a person would be nice with you but not nice to someone else. Yeah. So it is not constant for an element. It depends on how it is bonded to some other species. If it has single bond, multiple bond, if it is present in a certain medium, etc., etc. Lots of other things also change the electronegativity for an element. And again, someone said that I want to define how nice everyone is. So let's say you want to define how nice everyone is. So you define a scale on your own name. Let's say I want to define the scale of niceness. So I say that guy is 9 out of 10 on Pahul's scale of niceness. That guy is 5 out of 10 on Pahul's scale of niceness. You get it? I made my own scale. So similarly, a lot of scientists try to make a scale, try to define these numbers for electronegativity. Many scientists have done that. Mulliken has done it. Pauling has done it. There are some other not that common scales as well. But the one scale that we will follow, this one scale that is important for us, is this Pauling scale given by Linus Pauling. Mulliken scale is not asked in JEE and NEET examination, so you don't need to worry about it. You can read on it, of course. Okay, for self-study. You can read on the Mulliken scale as well. I'm not sure about the spelling, but Google will correct you when you search for it. ठीक है, तो ये self study कर लेना. After the class, just have a look. There's a simple division addition kind of a relationship between Pauling electronegativity scale and Mulliken electronegativity scale. Like you have a relationship between degrees Celsius and Fahrenheit. So similarly, there's a relationship between Pauling scale and Mulliken scale, but questions on Mulliken scale are not asked, so that's why we are not going to spend time on it. In case you want to satiate your curiosity, you can just do a quick Google search on it and read about it. It's most likely going to be there on Wikipedia as well. Anyway, so this is the guy Linus Pauling. Very smart scientist. He gave us a lot of standards. He is the guy who defined the idea of hybridization, which we will learn in the chapter of chemical bonding. So my dear friends, what does this mean? पढ़ तो लिया अपन ने, सब देख लिया. What does this mean? My dear friends, let's say a carbon is bonded with hydrogen. Yeah, whenever you form one bond, okay, whenever you form one bond, one whole bond is always 2 electrons. One single bond, one bond is always 2 electrons. You must say, no, sir, because there are banana bonds. You will learn about banana bonds later in the S block chapter, P block chapter, S block chapter में पढ़ोगे. So in banana bonds as well, you have 3 center 2 electron bonds. Whatever those bonds are, they are also 2 electron bonds. Okay? So these are the 2 electrons. 1 electron will be coming from carbon, 1 electron will be coming from hydrogen. They are going to share their electrons together. Yeah. Now, my dear friends, the thing is, out of these two, which will keep the electrons closer? Out of these two, which one will keep the electrons closer? So carbon versus hydrogen, the comparison is a little difficult. Let's try to compare, for simplicity purposes, fluorine versus hydrogen. So if there is a bond between fluorine and hydrogen, if I want to see it in terms of the electrons, where would the electrons be? Will they be right in the middle? Will they be shared perfectly among these two? Will they be a little bit towards fluorine? Will they be a little bit towards hydrogen? What is it? क्या होगा? And if you use a little bit of logic through the things that we have learnt in this chapter till now, you would realize that fluorine's effective nuclear charge will be more than that of hydrogen. Hydrogen has 1 proton. Fluorine has 9. Yeah? So the thing is that fluorine has more effective nuclear charge than hydrogen, quite a lot in fact, and you already know that fluorine as an element loves electrons quite a lot. So my dear friends, if you think in an ideal picture, the electrons are, uniformly distributed, as close to hydrogen as one is to fluorine. If you think that they will be right in the center, right in the middle, no. The electrons over here will be more towards fluorine. Why? Because fluorine has the tendency to attract the shared electrons toward itself more than hydrogen. This is electronegativity. Okay? In a bonded scenario, if fluorine keeps the electrons closer to itself than hydrogen, fluorine has higher electronegativity. If hydrogen keeps it farther from it, hydrogen has less electronegativity. So my dear friends, in order to define electronegativity for every other element, you realize that you need to define a standard. Yeah, if I have to define the nice behavior of every person there is, I have to define the nice behavior of one person. I would call that, okay, this person is my center ground. Out of 10, this person is 5. Then compared to that 5, I can compare the niceness of other people. That makes a little bit of sense. So similarly, Pauling fixed the electronegativity of hydrogen at 2.1. Okay, he fixed the electronegativity of hydrogen at 2.1. That gave the electronegativity of fluorine as 4.0. Okay, define hydrogen at 2.1. So fluorine becomes something around 4.0. Okay, so my dear friends, let's see the entire scale now. The image that I'm going to show you, this image is actually very easily available online. You must have seen this if you've attended other classes on this chapter. ठीक है, तो देखो यहाँ हो क्या रहा है. This is a very, very simple, very obvious idea. If you go from left to right, effective nuclear charge increases. So can you see that the number of electronegativities on the right hand side is higher? I mean, the value of electronegativities on the right hand side is higher. ठीक है, तो थोड़ा पढ़ने की कोशिश करते हैं इसको. Let's try to read this, and in case it is a little small for you, you can open this table in another tab on Google. Otherwise, just increase the YouTube's video quality. I'm pretty sure you'll be able to see it. ठीक है, तो अब करना क्या है यहाँ पे? Fluorine's electronegativity is given as 4.0, approximately 4. ठीक है, oxygen's is 3.5, nitrogen's is 3, carbon's is 2.5, boron's is 2. As you see, these are, fluorine has a bigger, fluorine has more elevation in this chart because it has more electronegativity. So these elevations in the chart refer to the magnitude of electronegativity. Yeah. Then if you come to beryllium, it is 1.5 and lithium is 1. My dear friends, The electronegativities that you have to remember, the values that you have to keep in your mind are for this particular period mainly. Apart from this particular period, if you can remember the electronegativity of chlorine and sulfur, it will be helpful. First period electronegativity should be absolutely ingrained in your mind. Sulfur, chlorine, if you can remember, great. Hydrogen, it's very easy to remember, 2.1. Cool. So ये चीजें याद रखनी है अपने को. Now, how do you remember this entire period? Can you see the pattern? Start fluorine from 4, decrease by 0.5, 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 decrease by 0.5. दिख गया? ठीक है. So if you go in the opposite direction, if you go in the opposite direction, तो आपका increase by 0.5 आ जाएगा. Increase, 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 increase. I was trying to make the arrows that I made appear again, but apparently not happening. Undo नहीं कर सकता बार बार मैं. Control Z. Not happening again and again. Anyway, I am pretty sure you understand what I was trying to say. ठीक है. So to remember this period is very easy. Yeah. Remembering hydrogen 2.1, simple. Fluorine, chlorine is 3.0. Sulfur is 2.5. My dear friends, do you see now? Oxygen, fluorine, sulfur, chlorine. Electron gain enthalpies, sulfur and chlorine were more than oxygen and fluorine respectively. Yeah, chlorine was more than fluorine, sulfur was more than oxygen in terms of electron affinity, electron gain enthalpy. But over here, since oxygen and fluorine are already bonded, sulfur and chlorine are already bonded, there is no question of electronic repulsion. You don't have to provide them new electrons anymore, isn't it? You don't have to provide them new electrons anymore. They are already bonded. Now that they are bonded, the electronegativity will depend on effective nuclear charge. And you know, when you go towards the right side in the periodic table, effective nuclear charge increases. When you go from top to bottom, effective nuclear charge decreases. Yes. So my dear friends, that is why over here, faith in atoms restored, no exceptions. ठीक है. Oxygen's electronegativity is 3.5. Let me take a blue pen to write the values. 3.5. Fluorine is 4. Chlorine is 3. Sulfur is 2.5. ठीक है. So oxygen and fluorine, no electronic repulsion over here in the picture because they are already bonded. अब और क्या repulsion होगी भैया? है electron तो पहले से ही है. The electron already is there. So this is what you have to remember, that fluorine is the most electronegative element in the periodic table. Fluorine is the most electronegative element in the periodic table, and if you look at cesium and francium, these are the least electronegative elements in the periodic table. Francium is radioactive, you don't really do a lot of reactions with it. Technically speaking, in practical terms, cesium is the least electronegative element. Okay, not least reactive, it's pretty reactive. Cesium is the least electronegative element which you can practically do reactions with. Cool. I hope you understood the idea behind electronegativities. So again, to give you an example, if you had a bond between carbon and hydrogen versus a bond between fluorine and hydrogen, yeah, carbon's electronegativity is 2.5, fluorine's is 4, hydrogen's is 2.1. So if you have a bond between carbon and hydrogen, you can imagine that the shared pair of electrons will only be slightly towards carbon. Yeah, you would expect ideally for it to be in the center, but it is just slightly towards carbon, just a slight bit of movement towards carbon. But if we talk about fluorine's electronegativity is very higher, so the electron pair will be very close to fluorine. Got it? If I'm comparing these two bonds with each other, again, this is just an imaginary diagram that I've made. Of course, in reality, electrons are not present like dots. They are those electronic orbital wave functions, which you know. Yeah. So we'll discuss more ideas about how electrons act when they are bonded in the chapter of chemical bonding. That's the next chapter that we will do after periodic properties. But I hope you understand that this is what we mean by the values of electronegativities. Cool. So my dear friends, always remember that electron affinity or electron gain enthalpy, यहाँ पे bracket में लिख देता हूँ electron gain enthalpy, this is defined for an isolated gaseous atom. Alrighty, this is defined for an isolated gaseous atom, whereas electronegativity is defined for a bonded scenario. Okay, it's defined for a bonded scenario. So when carbon forms double bonds, it has a different electronegativity. When carbon has triple bonds, it has a different electronegativity. Just giving you an idea that a singly bonded carbon has the least amount of electronegativity. A triply bonded carbon has the most amount of electronegativity. What's the reason? We'll talk about it in chemical bonding. Maybe not even in chemical bonding. We'll talk about it in the chapter of S block later. Sorry, S block भी नहीं, P block. तो उसके बारे में बाद में बात करेंगे, ठीक है. That why is that triply bonded carbon more in terms of electronegativity? Again, google.com is open for you, Wikipedia is open for you. You can search for that information, that why is triply bonded carbon more electronegative. Yeah, search कर सकते हो. But for now, we don't need to worry about it. Cool. So people, before I show you these questions, before I start doing these questions with you, I want to tell you guys, okay, that we hold classes for 11th class students over here. Okay, for 11th class students, our sessions happen every Tuesday, Thursday and Saturday at 7 p.m. Okay, for those of you who are in 12th class, which I mean by 12th class I mean that you haven't given your board examinations of 12th, which means that you have just gone from 11th to 12th class. You are targeting 2021 examinations, then your classes happen on Monday, Wednesday and Friday at 7 p.m. Okay, we are doing organic chemistry over there right now, and in case you are targeting 2020 examinations, then your classes will happen Monday to Friday at 8:30 p.m. Okay, got it? So this is the schedule of classes that we are following on this channel. Apart from this, we keep doing some motivational sessions, live chat sessions, some funny sessions, etc. That keeps on happening. Chalo, अब करते हैं questions. Let's solve the questions related to electronegativity. Cool, ready? My dear friends, let's get into it. Simple questions, won't take a lot of time. Once we are done with questions, we are done with today's class. As simple as that. Chalo. So the first question says the electronegativity of chlorine, fluorine, oxygen and sulfur increases in the order of. We just saw this, isn't it? क्या क्या values थी? Values भी पढ़ लेते हैं. Fluorine was 4.0, chlorine was 3.0, oxygen was 3.5 and sulfur was 2.5. Yes, told you to remember the values. So my dear friends, what's the order? Fluorine, oxygen, chlorine, sulfur. This is the order. Yeah, fluorine, then oxygen, then chlorine, then sulfur. Cool. So कहाँ पे order? Increasing order. अच्छा, fluorine, oxygen, chlorine, sulfur. Option number B is the correct one. ठीक है? Got it? So remember that electronegativity is different from electron affinity. Please read the question carefully. Why am I saying this thing again and again? You must be wondering, sir, why? We understood. Because 1.5 years later, 2 years later, when you are actually giving the examination, at that time you might forget what was electronegativity, what was electron affinity, was electron affinity this one or electronegativity this, that. You understand the confusions that can happen later. So that is why I am saying this again and again and again, so that your brains remember. Cool? Badhiya. Next question. The outermost electronic configuration of the least electronegative element in the periodic table is. क्या घटिया question है यार. The first one is fluorine, the second one is chlorine, the third one is an oxygen, but the fourth one, 6s2, 6p6, 7s1. What is this element? This is francium. Even if you did not know the element, you would know that a 7s1 species, something that is towards the left of the periodic table, will not be electronegative. This would want to lose an electron when you do any reaction. Yeah. Now, why does it do? Why does it convert itself into a positive charge? Why not a negative charge? I've explained it in the previous class, so please make sure you watch it till the end. At the end, I've explained something very important in the previous class, that is the chapter periodic properties, lecture 4. Okay? So this is the correct answer. Very simple, nothing complicated. Next question. The value of electron affinity for noble gases is likely to be. Electron affinity. Simply ask yourselves, do noble gases love electrons? Electron affinity is the love for electrons. So Do noble gases love electrons? Absolutely not. Noble gases don't love electrons. They are very happy with their own selves. Yeah, they are the saints, noble people. So electron affinity for noble gases is most likely going to be 0. No love for electrons, 0. As I told you, always think about electron affinity in terms of a qualitative nature, not a quantitative nature. Cool? Fine. So now, my dear friends, as we have this tradition of giving homework, yes, this over here, this question over here is your homework. Very beautiful question. I have dealt with it earlier in my sprint classes or something or the other like that on Vedantu's JEE channel. Okay? But again, if you're doing this chapter for the very first time, this is a good question. Let's read it out. A, B and C are hydroxy compounds of the elements X, Y and Z respectively. Okay, so A, B and C are hydroxy compounds. So bole to OH compounds. Okay, something like this is something like NaOH. Yeah, this is something like maybe you have AlOH whole thrice. Maybe you have MgOH2. Yeah, such kind of compounds, hydroxy compounds of elements X, Y and Z respectively. X, Y and Z are in the same period of the periodic table. Okay, narrows our search down to just one period. Which period? We'll decide it later. A gives an aqueous solution of pH less than 7. A gives a solution which is acidic in nature. B reacts with both strong acids and strong alkalis. B gives an amphoteric solution. C gives an aqueous solution which is strongly alkaline. C is basic in nature. Yeah. So basically the hydroxy compound of Z is basic. Which of the following statements are true? 3 are metals, electronegativity decrease, atomic radius decrease, could be. Okay, this is the question. So one piece of information that I would love to give you for this question, which is also important for this particular chapter, okay, is that if you have hydroxides, okay, if you have hydroxides, my dear friends, hydroxides में क्या होता है? If you have metallic hydroxides and on the other hand you will have non-metallic hydroxides. Cool. So metallic hydroxides are basic in nature. Okay, alkaline बोल सकते हो उनको. Alkali is essentially a solution which is basic in nature. ठीक है. So whenever you dissolve these metal hydroxides into water, it is an alkaline solution. ठीक है. Alkaline solution is a basic solution. In colloquial terms, alkali base same thing. Reality में just a slight bit of technical difference. Base is a base. Anything that you know. There are multiple definitions of the base. Arrhenius theory, Bronsted theory. All these theories we'll discuss in the chapter of ionic equilibrium later. But base is a more broad definition. Alkali is something that when you dissolve in water will give you a basic solution. Yeah, so in regular baatcheet terms, in colloquial terms, I keep using this word all the time. Okay, English with Pahul sir. So colloquial in Hindi, the word for colloquial is upbramsh. I don't know, षटकोण वाला श आता है या ये वाला श आता है. I'm not pretty sure which sh it is. I think षटकोण वाला है. Not sure. ठीक है, कोई भी हो सकता है यार. मेरी हिंदी की स्पेलिंग खास अच्छी नहीं है. But yeah, both the words are a little complicated. So this means that normal language which we use in conversation. Yeah. So whenever we speak Hindi, we are not speaking pure Hindi. We are speaking some words which are not even in the formal language. Yeah. So these informal words are known as colloquial. This informal usage of sentences and words is known as colloquial. So in colloquial terms, in general conversation terms, bases and alkalis are pretty much the same thing. Practically there's a difference. I mean, theoretically there's a difference. In colloquial terms, hardly any difference. Cool. So what I was saying is, metallic hydroxides when dissolved in water will give you basic solutions. Non-metallic hydroxides when dissolved in water will give you acidic solutions. ठीक है? Hydroxides, as I showed you, that is the way in which those compounds can be formed. Same thing applies for oxides as well, by the way. Okay, you might have studied this in your 9th and 10th class as well. शायद पढ़ा हो आपने, maybe those of you who were in ICSE must have studied it. So hydroxides, oxides will be something like Na2O, yeah, and you could also have sodium. You could have lithium oxides, yeah. You could have peroxides like this, KO2. Okay. What are peroxides? We'll deal with that later in inorganic chemistry. Inorganic chemistry is a vast science. Slowly and steadily we'll learn everything. Non-metallic oxides में you can have OF2 kind of a species, different oxides. So when you dissolve those oxides in water, again for metallic oxides, metallic hydroxides, they will give you a basic solution. Non-metallic oxides and hydroxides will give you an acidic solution. Cool. चलो तो यहाँ वापस आते हैं इस क्वेश्चन पे. ये रहा सवाल. This is the question that A, B, C are hydroxy compounds of the elements X, Y, and Z respectively. X, Y, and Z as in the same period of the periodic table. A gives a solution that is less than 7, which means A is the hydroxy compound of some non-metallic species. B lies somewhere in the middle, and C belongs to a metal. Yeah, so that is your hint. Try to do this question, very simple question. One more thing that I need to tell you about this question is that it is a multiple correct question. Okay, so more than one correct, multiple correct. Please make sure you keep that in mind. This is सिर्फ एक आंसर देके मत चले जाना. More than one statement could be correct over here. Cool. So once again, give me the answer in the comment section of this video. Leave a comment. As you saw, in the next class we will take your names. Okay? For some of you who give the answer the fastest, we will be announcing your names in the next class. Cool. So people, quickly summarizing what we've done today, we have understood what is electron gain enthalpy versus electron affinity. We have understood it in the previous class anyway. ठीक है. उसके बाद after some time I told you about the pro course as well, and this is something that you can join if you want to join Vedantu as a full-term coaching institute online, which is what you should do because it's a lockdown. Offline तो क्या ही करोगे अभी. So in such situations, Vedantu is a very good offer for you. It's a very good opportunity for you to learn, and you can check out the links for this pro course in the description box and the comment section down below. Coupon codes are also listed. You can subscribe to this course for 1 month if you just want to try. You can subscribe for 3 months, 6 months, 12 months, your wish. Then we understood, we just looked at this graph once again just to see the values. This is given in the NCERT. Make sure you are reading the NCERT apart from making notes in this class. Okay? We looked at the previous class's homework and then just revising the idea of successive electron gain enthalpies. First one could be exo or endothermic. Some successive ones, second onwards, will always be endothermic in nature. ठीक है, बढ़िया. उसके बाद some interesting cases. I live next to the highway. Some noises come. So we revise that chlorine's electron affinity. Chlorine's electron affinity is more than that of fluorine because fluorine will have electron repulsions when you try to provide it electrons. Then we saw this trend, we understood what are pseudo noble gas elements, and we realized that apart from noble gases and pseudo noble gas elements, there are more elements that are acting weird in the sense they don't want to gather any electrons, and those are beryllium and nitrogen specifically. You could notice the same thing for magnesium as well. Phosphorus is also not very keen on gaining electrons. Phosphorus ki bhi, it's the electron affinity is very less. But anyway, jo bhi ho, beryllium and nitrogen really important for us to keep in our minds, and the answer is pretty simple, that they have fully filled and half filled configurations. That is why they do not want to gain electrons. Then we came to these questions, very easy, very simple questions. We were able to do all of them very easily. Then we talked about electronegativity, qualitative measure, not quantity. Remember, niceness versus height. Yeah, so height can be measured, but niceness can't be measured until you define a standard on your own and compare people on it. So similarly, we are looking at the comparison that Pauling gave us. Electronegativity is the tendency for an atom in a bonded state to attract the shared pair of electrons toward itself. Why do I say shared pair? Because one bond is always two electrons. If there are multiple bonds between two elements, if you have a double bond or triple bond, you can call it shared pairs of electrons. Potato whatever. Then we looked at the Pauling scale of electronegativities. As I told you, it's very important for you to remember the entire second period. This is not the first period, this is the second period. So it's necessary for you to remember the entire second period. First period mein there's hydrogen. You must be wondering, sir, where are noble gases? See, since they don't react, we are not really worried about their electronegativities. You will be saying, sir, but xenon and radon react. Hardly worried about their electronegativities. ठीक है, फर्क नहीं पड़ता. So these are the values that you should remember. The second period, hydrogen, sulfur and chlorine. These are very important. If you can remember more, well, be my guest. Please do so. Alright. So ye ho gaya. Then after this, what did we do? We had reminded ourselves, this is like the 10th time I'm reminding you in this class, that electron affinity is different from electronegativity. Electron affinity is defined only for an isolated gaseous atom, and electronegativity is defined for a bonded scenario. Alright, this was the schedule of our classes. You can pause the video over here if you want to see the schedule once again. And then we practiced these questions. Again, very simple. You just make sure later on when you are doing this chapter again after 6 months, 12 months, whatever, please don't make the mistake of confusing electronegativity with electron affinity. And finally, this is a homework question that I gave you. Please answer in the comment section down below. For that question, I gave you this new piece of information, very important. Might have learnt in earlier classes that hydroxides and oxides of metals are basic and not metals are acidic in nature, something that lies in the middle. For species like metalloids, they could give you amphoteric oxides. ठीक है, cool. चलो, तो यहाँ पे all the ideas are given. Fine, cool. So my dear friends, thank you so much for joining this class. Again, the advantage of these premiered classes, this is not a live class, this is a class that we pre-recorded. The advantage is that I don't have to spend a lot of time in the chat box. It makes the class a little more efficient and it's easy for people to see. And anyway, most people watch the class after the live telecast is over. So that's the advantage. In case you have some doubts which you wanted to ask but you weren't able to ask me, please leave them in the comment section down below. As you saw today, I answered some comments from the previous class. Yeah, so please leave them in the comment section down below. I shall get to them eventually. And yeah, that's it for today's class. One more episode on this series remaining, one more class of periodic properties, and that will deal with a few questions and some other ideas that I want to tell you about. So that will happen on Tuesday at 7 p.m. Fine. So my dear friends, thank you so much for joining. Hit that like button if you enjoyed the class. If you learned something, hit that like button. Stay subscribed to the channel and I'll see you very soon. Bye bye. Take care. Ciao.